Hey there developers, this is part of a series going through what the solid principles are. Today we'll be going through the fifth of them, dependency inversion. It's the one that many people have the hardest time getting their heads around, so let's get into it. The idea behind dependency inversion is that we should have the higher level modules with all the complex processes structured in a way to be reusable. And as long as we follow the principle, it will be unaffected by changes in the lower level modules in the application. The actual definition of dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend on abstractions, or, for example, interfaces. Abstractions should not depend on details. Details, or in the case of concrete implementations, should implement abstractions. We effectively want to break down those strong bonds between bits of code and replace them with interfaces and patterns that allow us to not depend on implementations of code in other classes. Now, if that's confusing, let's break it down with an example. Does the business logic in an application really care where the data comes from? Or does it only care about processing the data once it gets it? We want the complex logic of the business logic to be abstracted away from the logic that deals with getting the data. Also, we want to make sure that the business logic can still operate if we were to replace the logic that gets the data. So as long as the pattern that gets the data is interchangeable, then the business logic really doesn't care. So we're going to have a quick look at an example to expand this. So here we have a data item. This is a concrete class. It has an ID and some data within it. This doesn't change. We then have an interface that defines how our data reader behaves. It will always have a method in it called getData, and we can implement that interface into some concrete classes. So we have two classes. One is a test data reader, which I can use to test some pre-canned data, which I might decide to throw into my business logic, which is great for unit testing. Or I might have a real data reader which might connect to SQL or something like that. But as far as the business logic is concerned, it doesn't care less. As long as I implement iDataReader, I know there's going to be a method called getData, and that getData will give me a list of data items. And therefore, whichever one of these I choose to use, it won't affect the business logic. The business logic will still behave the same way. So if we come down here to the actual business logic, we inject a data reader into this class. We tell this class that you are going to be using this data reader, and that data reader will have this interface. So you can always expect that there'll be a getData method for you to use so you can get some data to process in the business logic. That way, we know that this is always going to work the same way. The behavior, whether we replace it or not, will always be the same. And therefore, the business logic and the data reader have been separated, and they are having a dependency inversion principle applied to them, where the dependency is not going to break one or the other. So this allows us to be more flexible and replace parts of our logic easier. It also means that we can test our business logic by using pre-canned data. And it also means we have lots more advantages about being able to optimize code separately, but still be able to create strong interfaces between bits of code. I hope that's helped simplify the dependency inversion principle for you. For more videos, please subscribe and hit the bell icon to get all notifications. Thanks for watching.